Hello and welcome to today's lesson. To get access to our starter pack files such as blueprints, technical primer PDFs, native CAD files, as well as exclusive master courses, join our community on Patreon at patreon.com/ArielCad3D. You'll find the link in the description below. In today's lesson, we are going to learn about publication in CATIA V5, especially when you're dealing with an assembly and an assembly that also has multiple parts. Publication is one of the features that are very, very helpful. And when we are learning about publication, we are going to create the U-bolts. So for us to create the U-bolt, you can see the U-bolts are going to be joining our axles or axle housings and our suspension systems. So this is really, really important. You want to create collaboration between these parts. And when you are in the design phase, you want any changes that are made to the prior or the previous components to reflect to the new component, and that is the U-bolt. For example, if we are creating a U-bolt here, we want it to be constrained to this leaf springs, and we want it to maintain the constraints that we are going to add to the differential and rear axle housing. So publication in CATIA V5 is a very, very important tool, and it significantly enhances the design workflow by allowing users to manage geometrical elements effectively. So it's going to create collaboration, and it's also going to ensure that design changes are efficiently propagated throughout the assembly. So any design change that you make to the positioning of the axle should be propagated to the dimensions and the constraints of this new feature that you are creating. So how do we go about it? We are going to publish. You can publish faces, edges, points, plane, reference element, sketches. You can publish these things and you can use them either as a result or as a result with link. The difference is, as a result, you're only going to get, let's say you publish a sketch that was used in this part to the new part, and you're using it to create another similar feature, say between a female and positive geometry. So if you use it as specified, it will be as specified in the initial sketch, and any further changes will not be propagated. But if you use it as a result with link, then it means that new sketch is linked to the original one. So if you go back to the original part and make some changes in this assembly, those changes are going to be reflected in the new part. Let's do it practically. In this case, we're saying we want to create a U-bolt here. Very simple feature. So what do we need? One, we need a reference plane. We need it to be exactly at this position. So we can create an axis system here or a plane, and we can use it to sketch. Number two, we want that U-bolt to end at this last part or the bottom part of the leaf springs. You want it to be tight around this suspension. You don't want it to overhang or to be less. Therefore, we need maybe to publish this lower face. So we're going to do that, and then we're going to use those publications in our new part. Let's start with the differential and rear axle housing. So we have to go into that particular part by double clicking on the part. The part is signified by that gear icon right there. And once you're inside, you're saying you want an axis system here. So we can create a plane, say that is tangent to this face, or you can create a point. So I'll go to geometrical set, define and work object, and I'm going to insert a point using the center of a circle. I'm going to select this circle and select OK. Then I'm going to insert an axis system at this point, and I'm going to make sure that the reference is the default. So I'm going to clear selection, it's going under the current access system node and it's not the current one, then I'm going to select OK. So I've got an access system there. And you have to remember that this component, the main assembly, is the inverse of this in terms of the X component. You can see the X component for the assembly is going this way, but because when you are assembling, we rotated this, the X component of this new assembly is facing that side. If you would like it to face the front side, you can just inverse it. You can go to the X axis and select reverse. Let me check. I don't know why. You can say here I believe you can only reverse when you create a line. Maybe you define a new one and then you reverse. I'm not going to bother with that because it's not important. I don't want to complicate it. So we have created an access system, and we can take this new access system and go to tools. Where are we? Are we in the assembly? Oh, we're in the parts. We can go to geometrical set. Not geometrical set, sorry. We can go to access systems, select access system 7, tools, publication. Do you want to publish the selected element? You're going to select yes. Allow publication of everything, that's fine. And then select OK. I believe that's sufficient in our part. So that means if we move this component up, then the access system will move up, and the constraint of our geometry will also move up with respect to that. That means that view bolt can lengthen and shorten depending on the changes we make to the positioning of the rear differential and axle housing. So next we want to go to this part. In fact, you can double click on this part to switch between workbenches. Now you are in the leaf springs, and I want to publish the bottom face. You can either publish the bottom face or you can even publish the sketch and then constrain your new part to the sketch. Let's try the face at first. But you have to, one thing to keep in mind is faces can be unreliable. You might have to reselect them if you make some changes to the original sketch. Sketches, on the other hand, they are very, very reliable. So we might, I might publish the face, but also I want to see if we are getting the publications. So we've got the face, but also I'm going to select the, which one is this? Rear leaf blocks. I'm also going to select the sketch. Let me show the sketch. That is the bottom sketch. No. Sketch 25. Yes. I'm going to select sketch 25 so that if I see that, you know, the faces are unstable, you can opt to select this edge, this bottom edge of the sketch. So sketch 25, go to tools, publication, once again, select OK. I'm going to leave this sketch like that. Or actually I can hide it, because once I paste it, I can still show it. So we got a face and a sketch. Now we're going to create a new part and we are going to import our publications. So you're going to the chassis assembly. We will insert a new part. And because I'm creating both the rear and the front U-bolt, if it was just the rear, perhaps I can define the new origin and select this origin of this axis system. But in this case, I'm going to select no and just have a central origin. Also, I find it that when you're creating multi-assemblies, it's and you have a reference, say a blueprint, it's actually better to use the same origin when it comes to aligning features. All right, I can hide these planes. Now you can either just select this, copy, and use paste special to paste them into the new part, or you can try to import. Let's go to part 1. What are we calling this one? Part 1. Part 1 is the U-bolt. And you can specify that these are for the leaf springs. Okay. This is just the instance name, so it can be U-bolt 1, U-bolt 2, doesn't really matter. Now what I'm saying is you can just select this component, copy, come to say this geometrical set, paste special, and right here you can choose whether you want it as specified in the part document or you want it as a result with a link. And in this case, you can select a result with a link. And they are going to appear here. And perhaps it's better to just copy one at a time instead of both of them. So I will undo that. And I'm going to instead copy one at a time. Hold on. Paste, copy. Okay, copy. Paste special as a result with link. And right here we've got an axis system. Copy. So it seems we cannot just copy a face, but perhaps we can still use it. I understand why we can't copy a face. If you want, you'll just, you can publish the entire pad instead of the face. You can copy the pad. But thank God we used the sketch. I actually like the sketch more. It's easier when you apply constraints and publication in sketches because you can adjust that and you know the design is going to be propagated. The changes are going to be propagated automatically. It's always better to use sketches instead of faces, edges and stuff, but you can still use them. So we've got our sketch here, and we've got the new axis system. Let me first hide it so that I can hide the original one and the point. Nope. Let me double click on that. Hide the point. Okay, then come back to the new geometry. Okay, now with those two, we can now show our axis system and we can sketch the ZY plane. So we're going to create the guide, the curve that is going to be guiding our profile. Going to hide the ladder frame because it's in the way. So what do I want? I want to create some reference planes. So I'm going to frame back on this, create some reference plane or axis. The first one, I'm going to project this line because I want to know that bottom point as a construction element, of course, a reference point. And once we've got it, I can add an axis right here at the bottom to show me exactly. Make sure this is horizontal, like that, to make sure I've got a reference of the bottom part. Next, I do want, remember we are defining the center curve. It's at the center of the rib, okay, not the bottom part, not the upper part. Therefore, we know the bottom part is 15 millimeter in diameter, and this I believe is 20. So what I'm going to do is I'm going to create a circle like that. And if the inner one is 15 and our radius is going to be 5, then it means this should be 20, so that we have 5 and 5 on the outer side. You can change it if you want the diameter to change later on, but let's experiment with 5 millimeter diameter. That is 10 millimeter diameter or 5 millimeter radius. So we've got this curve here, and then we've got a 15 millimeter diameter from the center. So I'm going to create an axis running to the center, and I know that the distance between that center axis and this vertical axis is 20. So that's our central axis. With that, I can define a profile from this point. So this point between both axes, both the vertical and the horizontal, up to about this point, and then it goes up vertically up to that circle. So the distance, I can make this from here to here. Again, you want 15 plus 5, so 20. Oh, so that means we can actually just constrain this to the vertical axis, and we can make sure it sticks. Let's make it coincident like that. So it means we are going to have a 5 millimeter radius here and 5 millimeter radius on the other side. And I'm starting to think it's too thick, but let's go with it for a moment. We've got a 5 millimeter radius. Now you can add a corner here. Just make sure it doesn't exceed where we have our part. We can add a corner, perhaps a slight one, like that. So you just want to make sure that you've got 5 millimeter clearance on this side and it doesn't touch your object. And if we're creating actually the central curve, there is one mistake here that I'm going to correct. This is not going to be coincident. this is also going to have 5 millimeter gap. And this is what I'm saying, this is too big. 5 millimeter is too big. Can we actually reduce it? Let's see. Let's go with 2.5. Let's go with 2.5. 2.5 seems reasonable, right? 2.5, and therefore we're gonna have to delete this coincidence between line 14 and V direction. We're going to delete it, and instead we just want 2.5 from here. So that is 15 plus 2.5, that is 17.5. So we can define the distance between this and this to be 17.5. Yeah, that seems more reasonable. So it comes up here, and then we've got a curvature. Obviously we don't want it to complete, therefore I can add an axis from this center, cut out a piece, select trim this circle, so we've got a gap there. And instead you can actually add a tangent line, or even a horizontal one with a corner. I don't know if this is a good idea. Like that. You can bend it like that. We can also add a corner right here. This, if you want it to be exact, is about 7 millimeters. This is about 4. And I've cut it at this angle, the angle between the vertical. You can also define this if you want it to be standardized. This is 35. So we've got an eye here, which I'm saying can be flattened, can be hammered down to be flattened, and then we're going to secure it with a big nut or a bolt that is going into this threaded hole, and then secured with a cotter pin, whichever securing mechanism that you see fit. So we're saying that's our central curve. I believe it looks okay. I'm going to manually select it because I don't want to select the axis. Going to manually select it like that. Don't forget the corners. And I'm going to mirror in this direction. So one of the problems that I struggle with, and which I believe other students also struggle with, is when you're creating this center curve for ribs, we tend to, select the edges, the inner curve or the outer curve. So we have to really mind where we are placing them. We allow for half the diameter of the radius on both sides, on this side and on the other side. Same thing with the bottom section. Same thing with the corners. You make sure that if you add 5 millimeter or 2.5, that is 2.5, it's not going to protrude or to exceed where we have our geometry here. So we can work with that. Now we need to create the profile. And the profile, the best way to create it is either on the XY plane or on the ZX plane. You can create it on the ZX or on the XY. And we are going to move our profile to the center curve, so it doesn't really matter where we put it. I'm going to select the ZX. And we just need a circle. With a diameter of, we said 5. 2.5 on each side. And now we create a rib. This is our center curve. Why does it lead to a twist? I want to select a pulling direction, and I'm going to select x-axis as our pulling direction. And I'm going to move profile to path. That should work. So when you're selecting pulling direction, you want one that is either parallel or not parallel, but you can select one that is perpendicular. For example, you see this geometry is running in this direction. You can select an x-axis because that is neutral for every single part of this sketch, the x component. So we're going to have even geometry, including at these center edges. If you select keep angle, you might find it slanted or things like that. All right. So we're saying you can either hammer this down to flatten it, and we might have to move it a little bit because it's eating away at our previous geometry. You can see it here. Alternatively, you can make sure that this radius clears out of this part onto the outer circle, like the inner part of this curve is the outer part of this circle, and that would be too large. I don't know how I feel about that, but just to show you practically, you have sketch 2 and 3. Sketch 2, we're talking about the diameter of this circle. So in this case, I use, where is the diameter? We use 20, I believe so. Is it this one? No, this is for the curve. It's right here. We used 20. Okay, let it just stay there. So if you want it to clear out, it means you need to add 2.5 from this section, and that would be 22.5, right? So let's try 22.5 and see how that works. But then remember, we have this section down here which is going to eat away in the material. So 22.5 is supposed to clear it. And if you add 22.5, if for example you want to move this into this outer section, where is it? Reframe. You can delete this part. So I'm just giving you options. Into the creative process. You can delete that part. Like so. So you only have a curved section. Wait, 22.5 should clear it out. What are we missing? This is 20. Is this 20? Let's confirm. What's the diameter here? That's 20. Let me try 25. Okay. So 25 to accommodate the entire diameter. And then you can say, in terms of security, if you're not going to hammer it down, you can translate this geometry. I'm going to select it here. Or here, the rib. You can translate the rib in X direction. No, I want the X component. X component. And you can loop it over like that. And then say you're going to secure this place with a large bolt that has a cotter pin so that it secures this in this position. But if you ask me, this is going to be very unstable because it can move in and out, although you can use this geometry to secure it. So let me go to that, translate. Just want to make sure it's not merging to this part. So it can be hanged there and then secured. But if you ask me, the original part that we had is the most viable one, where it's just pressed again, is this part. I would go with that personally. We just try to undo. Like that. And then I'm going to assume that we are going to hammer this flat and secure it with a nut or a bolt that's going inside here.